These are your 10.5a notes, the Pythagorean Theorem and its converse. The Pythagorean Theorem, I'm hoping, is familiar to you from middle school. It is the rule or the law in math that says the sum of the squares of the measures of the legs of a right triangle are equal to the square of the measure of the hypotenuse. So to fully understand this, we got to make sure that we have a picture, and just to go over some geometry criteria, even that's where we're heading next in your math progression. These points with the capital letters are your vertices, and so we always label the vertices of a figure with capital letters. And then the sides opposite those vertices are labeled with a lowercase letter. So the side opposite vertex A is side little a, the side opposite vertex B is little b, and the side opposite vertex C is little c. Now in a right triangle, you have a right angle. This little box signifies a right angle, and the two legs, the two sides that make up that right angle are called the legs, and the side opposite that right angle is the hypotenuse. It's important to know which one is which. In the Pythagorean theorem, this is true for every single triangle. Theorem is just a name for a law that has been proven. So Pythagoras, a Greek mathematician, found this to be true for every single right triangle. And so he proved it, and so he got to name the rule. So the Pythagorean theorem is his. And so what it basically says in symbols, a squared plus b squared is equal to c squared. The sum of the legs squared is equal to the hypotenuse squared. It's really important that you take the two legs and add them together and set it equal to the hypotenuse. The hypotenuse is the longest side of the triangle. It's opposite the largest angle. And so that always has to be the largest side. So in using the Pythagorean theorem, if you have two out of the three sides, any two, either the two legs, you can find the hypotenuse, or if you have the hypotenuse and a leg, you can find the other missing leg. So we always start off like any other formula with just that formula. So in this first example, a squared plus b squared equals c squared. It really does not matter which one you call a or b. So I'm going to put the 18 as my a squared plus 24 squared is equal to the hypotenuse squared. And when you actually do the calculations here, 18 squared is 324, and 24 squared is 576. And so when you add those two together, you end up with 900. So 900 is equal to c squared. We're not done yet. We have to actually figure out what the hypotenuse side is. So to undo that squared, we take the square root of both sides, and c is equal to the square root of 900, and the square root of 900 is 30. Now, technically, anytime you take the square root of a number, we always say plus or minus 30. But when we actually apply it to geometry, and you're talking about a side measurement of a right triangle, you can't have a negative 30 side measurement of a right triangle. It does not exist. So we throw out that negative option. So depending on, in real life, a lot of times we throw out the negative, or in this case, in geometry, because you're talking about an actual length. You can't have a triangle length negative 30. Length is really just another name for distance. Part B, same concept. We're going to use that Pythagorean theorem, but this time they're giving us the c value and they're giving us a leg. We're going to find the b value. So a squared plus b squared equals c squared. I'm going to call 9a squared, leave b for b squared, and make sure that you put the 16 in for the hypotenuse squared. Remember, the hypotenuse is always opposite the right angle. And so we get 81 plus b squared is equal to 256. 256 is what 16 times 16 is. And then we're going to subtract 81 from both sides. And when you subtract 81 from both sides, I get b squared is equal to 175. When I take the square root of 175, I realize that it's not perfect. 175 is not perfect, and so I'm just going to leave it as square root of 175, but I can pull a perfect out of it. So I know that 25 goes into 175 7 times. So we're going to use that skill that we just tested on in simplifying radicals. And so you take the perfect and the non-perfect. B is equal to 5 root 7. And that is how long that hypotenuse is. Now, when you look at 5 root 7, it's kind of hard to see that it is longer than the 9. Or not longer, but it's 5 root 7 should be smaller than 16. If it's not, we did something wrong. So 5 root 7, actually, if you looked at its decimal part, 5 root 7 is equivalent to 13.2. So it is smaller than the 16. And just to check over in part A again, when we got 30 as the hypotenuse, we want to just check it and make sure 30 is the biggest side. So that's a good sign that we're doing it correctly. So that's the Pythagorean theorem. 2 more things we're going to cover in the Pythagorean theorem. We're going to cover what's called the converse of the Pythagorean theorem, and then what a Pythagorean triple is. The converse is basically saying if you can add up 3 sides and the Pythagorean theorem holds true, then you know that those 3 sides could make up a right triangle. You can't just randomly pick any 3 numbers and get a right triangle. You can pick any 3 numbers and make a triangle, but it may not be a right angle. In order to make them connect, it might be an obtuse angle, or they might all be acute angles. So in order for it to be a right triangle, the Pythagorean theorem must hold true. And so that's what the converse is saying. The converse is just kind of the opposite order. So in the Pythagorean theorem, you know you had a right triangle, therefore a squared plus b squared equals c squared. In the converse, you know that a squared plus b squared equals c squared, therefore those sides could be the sides of a right triangle, with the biggest one being the hypotenuse. So that's all the converse is saying. And so if you have, let's just do it in a symbol format, you have a triangle, and you had triangle ABC, and we know that ABC. So what this is saying, if a squared plus b squared is equal to c squared, then A, B, and C are sides of a right triangle. And we know that C is the hypotenuse in this example, because C would be the biggest one. A Pythagorean triple does what we just said in the converse. So it's 3 numbers that make up a right triangle, but they have to be 3 whole numbers. So the key here is there's lots of different combinations of 3 numbers that satisfy the Pythagorean theorem, but to have whole numbers. So if you look at our first example, A, 18, 24, and 30 would be considered a Pythagorean triple. But in part B, even though it works, it's not a Pythagorean triple because of that 5 root 7 is not a whole number. It's an ugly decimal. So when it works and it actually is whole numbers, then you know it's a Pythagorean triple. So that's just some vocabulary for you. So we're going to take these 3 examples and we're going to decide whether or not they're Pythagorean triples. And not only that, we're going to see if they actually are or could be the sides of a right triangle. So if I had a 9, something like maybe 9, 12, and 15, and I wanted to create a right triangle, would I in fact be able to make a right triangle out of that, or would it turn into an acute or an obtuse triangle? Rather than actually having to cut this out and measure it, we can do this mathematically. So using the Pythagorean theorem, I'm going to call 9a, I'm going to call 12b, and I have to assign the largest number as the c value, because that's your hypotenuse. So we're going to check. We don't know if it works. A squared plus b squared, we're questioning, does it equal c squared? Does 9 squared plus 12 squared equal 15 squared? That's 81 plus 144. Does that equal 225? That's what they're asking each time. And in fact, it does. 225 is equal to 225. Because we got both sides of the equation to balance out, that tells me that 9, 12, and 15 would in fact be the sides of right triangles. So if you read the directions, it says determine whether the following measures could be the sides of a right triangle. The answer is yes. Right triangle. And then it says determine if they are a Pythag triple. And the answer to that is also yes. And I'm just going to clarify what I'm saying yes to. It's a Pythag triple as well. Not only are they the sides of a right triangle, they are also whole numbers. Number 3 here, we got the same thing going on. So I'm going to assign 54 as my C value. So I'll call 21 my A and 42 my B. Your C value is your hypotenuse, always has to be the largest. Is A squared plus B squared equivalent to C squared? Is 21 squared plus 42 squared equivalent to 54 squared? That's what we're asking. I always put a question mark there. I'm not saying it's true. I'm wondering if it's true. So 21 squared is 441. 42 squared is 1764. And I'm wondering if that adds up to what 54 squared is, which is 2916. So when I add up the 441 and the 1764, I end up with 2205. 2205 is not equal to 2916. So to answer the question here, no, not sides of right triangle. This would create some other triangle, and therefore not a Pythag triple. You can't be a Pythagorean triple if you don't satisfy the Pythagorean theorem. And the last option, number 4 here. Again, I'm going to say A, B, biggest one, C. A squared plus B squared, is it equal to C squared? That's 6 squared plus 12 squared, is it equivalent to 18 squared? 36 plus 144, is that equal to 324? And when you add 36 and 144, I get 180. 180 is not equivalent to 324. So this is a no, no. Not the sides of a right triangle, not a Pythag triple. I didn't give you an example, but I would like to go back to the notes over here, and we could say that 9, 5 root 7, and 16 make the sides of a right triangle, but are not a Pythag triple. Okay, so just because they're not perfect doesn't mean that they can't be the sides of a right triangle. So you can have sides of a right triangle, not a Pythag triple, sides of a right triangle, and also a Pythag triple. But if it's not the sides of a right triangle, it cannot be a Pythag triple. All right, so that concludes the Pythagorean theorem. We are almost done here. I want you to describe the criteria for a Pythagorean triple and then determine if 30, 40, 50 could be the sides of a right triangle. Show all your work. Good luck.